Hello friends, welcome to my channel. Let's have a look at problem 1814, count nest pairs in an array. So this problem actually is essentially the same as Leetcode 2426, 6364, 493, etc. So here we still present two methods. The first method is dictionary and check, and the second method is direct count. So first, I'll read through the statement to digest the requirement, and then we do the analysis and share the code. So first, let's look at the statement. So we are given an array nums that consists of non-negative integers. So we define reverse of x as the reverse of the non-negative integer x. So here is an example. The reverse of 1 to 3 is 3 to 1, and the reverse of 1 to 0 is 2, 1. So ignore the leading zeros. A pair of indices ij is nest if it satisfies all of the following conditions. So first is that I and j are in bound and I is strictly less than j. And secondly, this equation holds. So it involves two indices. So we are required to return the number of nest pairs of indices. Since the number can be too large, return it modulo 10 to the power 9 plus 7. So here are two examples. So in example 1, so the output is 2. So in the explanation, the two pairs are specified, 0, 3 and 1, 2. So in example 2, so the output is 4. So we're going to analyze the output of example 2 in the analysis part. So before we look at the analysis, let's also look at the constraints, or we may regard them as additional assumptions. First is that the length of the nums list is bounded below by 1. In particular, it's not empty, and bounded above by 10 to the power 5. And so this constraint actually defines the problem size. So the second constraint is on the range of elements in the nums list. So with that said, we are ready to look at the analysis. So as we mentioned, actually we now look at this problem or revisit this problem after we solving a problem 24, 26, and their related problems. So here we are going to look at the two methods again. So one is dictionary and check, and the other is direct counting. So the second method is more specific to this problem itself, and the first method is of general purpose. So we emphasize this first method. So both the two methods actually based on the observation here. So this is the main condition, so given by star, so copied from the problem statement. So this is equivalent to the double star. So we just make some simple arrangement mathematically. So these two are mathematically equivalent. However, so their viewpoints changed if we transform from star to double star. The reason is that in double star, the two indices I and j are decoupled in the two sides. In other words, the left hand side involves I only. Similarly, the right hand side involves j only. So this way, actually, it enables us to examine the difference list. So I call it auxiliary. So in other words, we can compute the nums I minus the reverse of this number for each of the elements in nums. Then we just focus on this aux. So first, let's look at the direct and check method, dictionary and check method. So the idea is actually very simple. When we do the linear traversal, what we are going to do is that when we look at each item in the aux, so it corresponds to an index j, right? What we want to find is the previous i's with those can pair with j to form nest pairs. So for this counting, we just need to use a dictionary. So this is very routine. So in this regard, actually we can regard this problem as an extension of the classic two-point two-sum problem. So let's use example 2 to do a digest. So this example 2, right? So if we compute the aux, so 13 minus 31, 10 minus 1, 0, 1, that is 1. So similarly 76 minus 67. So in other words, if we compute these numbers, so negative 18 and 9s. So if we look at index 0, so there's no left indices, so it corresponds 0. So if we look at 9, so to the left there's no 9 appearing, so we get 0. So if we look at negative 18, to the left there is 1 negative 18, so there's a good pair, so we add 1. So if we look at the second, this index 0, 1, 2, 3, index 3, so this is negative 18, and to the left there are 2 negative 18s, so this contributes to 2 good pairs, so we add 2. So now if we look at the last index, that is index 4, so to the left there is 1 9, that is index 1, so it contributes to 1 good pair, so we add 1. So in total we get 4. That's the return in example 2. So this is the first method. So now let's first do this coding. So then we look at the direct counting method. So for this, we're going to first we introduce a constant. So this is not absolutely necessary, but we want to make our code modularized. So this is 10 to the power 9 plus 7. So actually do not forget to modulo this number. So if we do not modulo this number, so get a wrong output. And then we're going to get the aux first. So this is actually very easy. So what we're going to do is to use a list comprehension. So y, then we're going to first change this y to be a string, so that we can use the reverse, right? And then we compute the integer corresponding to this reversed string. And then so we just for y in nums. So this gives us the difference list aux. And next we can do the for loop. So for this we can initialize a result for the counting, and we'll also use a dictionary for recording. So and then we do the for loop. So for y in aux, notice that we do not need to track explicitly the indices, right? So for y in aux, what we are going to do is to increment the result by, so how many y's appear in the previous state of the dictionary, that is d get y. So if y is not a key, so we're going to set it to be 0. And then we're going to update this dictionary. So in other words, we get the previous frequency. If it's not in the dictionary, so we're going to use 0 as default. So here we overall we want to add 1. So that's the for loop, that's the dictionary and check step. And then we're going to return a result modulo this capital C. So actually in between, if we update this result, we can do this modulo operation. So also let's first do a special case check. So solution object has let's change the function signature. Let's check again. Yeah, it passes the first example. So now let's look at the generic case. Oh yeah, it passes all the generic cases. So here, this wrong answer actually is due to the fact that we forgot to modulo this capital C, the large number. So as we mentioned, so if you want to, you can also do the modulo here. So let's check again. So that's also okay, but it's not necessary. Let's see. So this is the first method. So we're going to use dictionary and check. So this is actually a general purpose method which can be used to solve a wide variety of problems. So for this specific problem here, so actually we can use direct counting. So the reason is that we want to find nice pairs or good pairs. So we still use the auxiliary list. So for example 2, the auxiliary list is given here. And then after we get the auxiliary list, actually we can do a counter. So we can find the unique value and their corresponding frequencies. And then we do the counting, right? So we just sum with this kind of expression. So for v in frequencies, if v is greater than 1. So for example, the aux corresponding to example 2 is given here. So negative 18 appears 3 times, and none appears twice. So the good pairs, so this corresponding to 3 indices, so we can choose any of 2. So we can choose 3 choose 2, that is 3, right? So this is 3. And 2 choose 2, that is 1. So 3 plus 1 is 4. So this is the second method. So actually for the second method, it's very easy to coding. So we can actually even use one line, but let's write some details here. So let me change this to be v1. And now let's do the counting. So first I'll count, I'll copy this one, copy this theme. And then also I'm going to get a counter. So collections counter. So we are going to use this aux. So let's copy this directly. And then what we are going to do is the return, right? Return the sum. So I can use iterative form expression. So that is v times v minus 1 divided by 2. This corresponds to choose 2 out of v. So for v in d values, if v greater than 1. So actually this if condition is not necessary, because if v is 1, so this is 0, right? But let's use this filter. So with that said, so we finished the second format of solutions. So now let's look at check. Yeah, it passes the first example. Now let's look at the generic case. So wrong answer. Let me see where is the wrong. So again, so we need to modulo this letter C. Let's do the check again. Yeah, it passes all the cases. So it's important to modulo this C according to the problem requirement. So with that said, so that's about it for this video. So here we presented 2 solution formats. So one is a direct counting, which is specific to this problem, and the other is a dictionary and a check. So this method is what we want to emphasize because it's of general purpose. So with that said, that's it. Thank you.